So today we will be solving the Leetcode question 98 validate binary search tree. So given the root of the binary tree, determine if it's a valid BST. So what is a valid BST? A BST is simply valid if the left subtree of a node contains only the nodes with the key strictly less than the node's key. That is, all the elements to the left of 2 will have values less than 2, and all the elements to the right of it will have the values that is greater than. So this is a valid, we can say a BST. And also one more thing, that both of the left and right subtrees must also be BST. So in the second example, we can see 1 is obviously less than 5, but the 4 is not greater than 5. That means the right subtree is not proper. That's the reason this whole tree is not a BST. So let's just uh, see this in a whiteboard. Okay, so it will be easier for us to visualize. Okay, so this is a binary search tree, you can say. So what we can do, let's say we can do some basic DFS or BFS. Let's consider DFS. We can go with that twice. Right, so let's first consider the root node. Right, so what we can do, we can check if the left node of the BST is less than that node, right? So there is, we can check if node dot left is less than the node value. Node dot left of value, okay, is less than the node of value. So we can say it is less. So that's correct. We can check if the right value is less. So it is less. So that is also correct. But this approach won't work. Okay. So here what will happen if we check so this value doesn't work properly. So this will definitely give us some error. But let's assume uh, there's some example, like let's say 15, 1, and to the right of it, let's say we have 10, and to the left of 10 we have like 6, and right of it we have 20. So in this is also not a valid BST, because 6 should have been to the left of 15, but in this case it's in the right branch. So if we just check left and right subtree at that given point, so for 15, left is less, the right uh sorry, let's instead just swap these two positions for 15 and 10. I did the same thing. Yeah, so for the value 10, 15 is greater, so that is a proper, we can say, proper condition for a BST. In the when if we consider now the node 15, the value 6 is less than 15 and the value 20 is greater than 15. That means that is also a correct binary tree. But overall, this is not correct, because the value 6 is to the right of 10. But actually, the value 6 is less than 10. That means it had to be on the left branch of the 10, right? Mostly it should have been around here. So due to this, we have to actually maintain, we can say, a range of values. Like all the values that are to the left of 10 should be from 0 to, we can say, if we consider same values, or we can say actually 10, we can consider 10 values. And all the values to the right of it, we can say, should be from 10 to, maybe we can say, infinite, right? So in the case of 15, we can say all the values to the left of 15 should be from 10. Okay, because it is to the right of 15 is to the right of 10, right? So all the values that will to the left of 15 should be from 10 to 50, right? That is the node itself. And all the values to the right of 15 should be from 15 to the right max. All right. So that's how the 6 is invalid, because the 6 does not lie in the interval 10 to 15. Okay. So that means while checking, we have to also check the intervals. So we have to, in the DFS, while doing the DFS, we don't just pass the node, but we also pass the left and the right, we can say, limit of that node. Okay. So let's start the basic implementation part. So obviously we'll be doing the um, DFS. So let's start by defining a function for DFS, right? And we'll be passing the Boolean function because we have put it in either true or false, right? Yeah. So as I said, inside we'll be passing the node and the node, and also along with that we'll be passing left and right. For now, let's define it as maybe end. All right. I'll tell you later. We have to make some changes here. I'll tell you why. So right now, let's focus here. Let's check for a base case, that is if node equal to null, obviously you have to return true because a single node is obviously a proper, we can say, a valid BST. And here also let's just call the df function before. So we'll pass the root node, and along with that we have to pass the left minimum limit, and we can say a right minimum limit. So the left minimum limit for integer is integer dot underscore value, and for the right we have integer dot max underscore value. All right. So let's start by checking these the values of the node. All right. So when do we return false? Right. If that node's value is not lying between the range of the between the specified range, then we can say it's not a valid BST, and node is false node. So let's say for the node 15, the left value is 10 and right is infinite, right? So to check if the node val is it we can say less than or equal to the left limit, or is the node dot val greater than the right limit, greater than or equal to, we can say, the right limit. At that moment we can say it should return false, right? Because it's not a valid node. Like if the 15 value, if it's less than 10, okay, let's say it's 9, then 9 is definitely not a valid, so it has to return false. All right. And obviously if it's satisfying both of them, then we have to go to the left and right. We have to perform the same operation on the left and uh, right childs of that node, right? So we can specify something like this. So we can apply DFS for node left and also for the node right. But now it's the important part to define the range. So for the node dot left, all right. So let's consider by using this example because it's quite easier to understand using a simple example. We can visualize it properly. So let's say for 6, we can say the left value of 15 is 6, right? So for 6, the left limit will be 10. Now why 10? Because we are already to a right of the right branch, we can say right subtree of the 10, right? So that's the reason our left limit should always be 10. That means the value should be, we can say, greater than 10, right? So left value will be left. Now why left? Because left we are storing it here for the 15 as well inside the left variable, right? It's left, we can say, limit, left barrier. And the right value obviously will be, it has to be 15 because it's to the left of 15. So right value is 15, so that we can say no dot val. Okay. Now for the right, for the 20, our left value will be 15, that is the no dot val, correct? And right value obviously will be the maximum right limit, that is right. And That is yeah, so that is it. So let's check by running it. Let's check for any syntactical error or anything. Okay, so we are missing back. Let's check for any syntactical error or anything. Yeah, so it's working properly. So there's one edge case here that it will fail. That I'll just show you guys. So that is for this value. So if you know the minimum and maximum length of an integer, you will know this value. You will recognize this value easily, right? So what is happening basically is this, because the root dot val inside the root dot val we are storing this in as an integer value. An integer value has a max limit of this. Let's say 2147 dot dot dot. So when this condition arrives, okay, and if for this value, if we check this 21, okay, let's say 214 for now, okay, dot dot, is it is less than or equal to, and the right limit will for this we can say is also 2 1, right? So this condition will satisfy, right? This condition will satisfy and it will throw false. That's the reason it is giving false. But actually, it should not give us false. It should be true. It should give us true, right? So so that's the reason we have to consider here the maximum value of a greater variable. Let's say we can consider long. Okay. Also we'll add long here in the left and right. Let's check now. Oh, sorry, I had to submit it. Let's check now, and it's working properly. So that's the exception, we can say, an edge case. And talking about complexity, the space complexity will obviously, let's say, it will be um, because we are storing the values inside left and right. So it will be space complexity for this will be O of n. And the time complexity will also be O of n because we are traversing all the nodes within the tree. Okay, all the nodes and within the tree. That's the reason. So yeah, thanks for watching.